In this episode, I talk with Crystal Parrot, who is the COO at Plus One Robotics. Plus One is a San Antonio-based robotics company that focuses on using robots for depalletizing and parcel sorting. These are important problems because of their sheer scale. Think of how many packages companies like Amazon send out to customers. This problem is made more difficult because people often return things, and they often pack up what they're returning badly, using whatever they have around. Are you guilty of this? I know I am. And bad packaging makes it much harder for automation. For example, what happens if a robot can't safely pick up a box because it's been ripped in transit? This leads to a huge loss of productive time. What Plus One does to solve this problem is that they put a human in the loop that helps the robot when the robot identifies that things are a bit off with a package. I'm a big fan of the human in a loop model because it often lets you go to market faster with less cost and provide value to your customers before you've solved the problem, especially those pesky edge cases. You're also getting hands-on experience and data with the problem, and you're getting feedback from your customer. Plus One does this in a clever and pragmatic way. I think you're going to like this interview. On a housekeeping note, did you know that just over half of you are not subscribed? That's crazy. If you're enjoying this interview and want to make sure that you don't miss our new content, make sure to subscribe. It also helps the channel a ton. I'm Audrow Nash. This is the SenseThink Acts podcast. Thank you to our founding sponsor, Open Robotics. And now here's my conversation with Crystal Parrot. Thanks for listening to this conversation with Crystal Parrot. If you like this interview and want to see more content like it, make sure to subscribe. Also, likes and reviews help a ton. Thanks for watching. See you next time. All right. Hi, Crystal.
Well, hello. How are you?
Doing well. Would you introduce yourself?
Why, certainly. My name is Crystal Parrot, and I am the Chief Operating Officer for Plus One Robotics, and I've been here since 2020.
Would you tell me a bit about Plus One?
Absolutely. So Plus One is a company that provides software solutions for enabling robots in the warehouse and logistics space to be able to have that hand-eye coordination, to be able to pick and place parcels within a warehouse or distribution center. So primarily our focus is to be able to enable robotics in warehouse and logistics via software, 3D cameras with AI augmentation to be able to intelligently understand its environment, and then it allows it to consistently learn throughout its process. So we have been in business since for 5 years.
So exciting.
Yes, it was very exciting. Eric Nieves was the original founder. He comes from Yaskawa, which is one of the largest robotic manufacturers in the world. And he was their technical director for Yaskawa North America. And he was the founder of this, seeing the incredible opportunity that Ross Industrial offered the space to allow for applications to be able to use on robots independent of robot type. And he was joined by Sean Edwards and Paul Voss, who were Sean was the founder of Ross Industrial and brought that from Willow Garage. Ross Industrial is robot operating system.
Yep.
And it's used a lot in colleges for development and research. So it's just Ross.
Yep.
And so Sean had an opportunity to go to Willow Garage while he was at Southwest Research as a researcher developer. And
Southwest Research is the Southwest Research Institute, where Ross Industrial is, and they're a huge research campus.
Correct.
In San Antonio, Texas.
It is in San Antonio, Texas. And what's interesting is we went from Southwest Research, we were interested in, any kind of application that made integration with any type of robots easier versus having to do custom coding on robots by type, having to know their special language, their special teach pendants, more of a universal layer that would allow applications to be developed independently and just interface with robots. all manufacturers. So you never had to rewrite the application.
Yeah.
And when Sean went to Willow Garage and was instrumental in looking at just ROS, which was being used in the development community, he's like, you know what, if we industrialize this and harden it for a manufacturing environment, it could be very powerful. And so he brought that concept back to Southwest Research Institute and launched ROS Industrial and created that platform and started that user community. And Paul Voss happened to be a project manager that became the Ross Industrial Consortium manager. And so he launched the consortium for global use of, Ross Industrial in applications for robotics. And so we had a huge number of developers that were creating all kinds of applications using Ross Industrial with a variety of robots and manufacturers, from KUKA to ABB to FANUC to Yaskawa, really highlighting and showcasing that its interoperability with the different robot manufacturing platforms.
Interoperability, right?
Interoperability.
Yes, because it works with all the different platforms.
It does. And so, from that, they started and developed a really interesting parcel singulation application.
What does that mean?
And what it means is that
Could pull out one parcel from a group of parcels?
From a group of
Singulation,
parcels.
I imagine making single kind of thing.
Making a single from group. And if if you are familiar with a lot of the shipping companies, USPS, UPS, FedEx, DHL, UPS, how they process their parcels from a distribution component, they get them in big bags or big totes or big sacks, and they dump them on these big conveyors that then go to an individual who then has to singulate them and put them on a sorter that can then be sorted to destination. So basically it comes all in from one area and then has to be resorted to go to the next level of regional distribution, and then it goes to the next level of...
It just keeps doing that
until it gets to the person. And so all of that is singulation from a big bulk to an individual item for resorting to another area. And it's a very difficult problem. A lot of people do this manually. It's very labor intensive.
I bet.
And there is no, especially with e-commerce, the need for that is only increasing.
What do you mean, especially with e-commerce? Like, especially with Amazon and things like this?
Absolutely, because everybody has to have tons of packages shipped every day.
Yes.
Versus, it's not just mail anymore, or just at Christmas time. It's constant and total. COVID helped with that, only because people had to order from home because they weren't able to go anywhere.
Yes, definitely.
But the need for getting parcels and pieces from one position to another position has been ever growing since the inception of online ordering.
Yes, definitely.
And so that creates another need, that they're making more and more warehouses with less and less availability of labor. So
you mean
those
fewer
companies
people to work for these jobs, for sorting it out and doing the next routing stage.
And they're all competing against each other for
trying
those
to find
people.
Efficiency gains. Oh, and competing for the people. Yeah.
And if you know anything about that type of distribution, the willingness of individuals to want to work in those environments is becoming less and less tolerant. Most of these facilities are not fully conditioned, which means they're open to the outside environment.
So they're hot.
So they're hot or they're cold, depending on which time of year you are. They could be very humid. And in that case, it can be difficult. It can just be a difficult work environment.
Yeah, it's just unpleasant, for sure, to work in.
Packages are heavy.
Yep.
The number of packages are increasing.
Yeah.
The time expectation for delivery is decreasing. So it's an ever evolving, fast-paced job that is just not very stimulating to the mind.
Yeah, it's tough, and it doesn't require that much skill, like training. Like, you can probably be trained in a day for this kind of thing, and then it's low paid also. I would assume.
It's low paid,
Relatively.
relatively. I think it's the repetitiveness that gets difficult. The speeds at which you're singulating parcels can be anywhere from 800 to 2,000 an hour, depending on your application. So if you
So
can,
800,
in
that's
800,
like 10 a minute or roughly 10 a minute? Gotcha. 2,000 is 20 or I don't know, 20, 30 a minute.
32 a minute.
That's a lot.
Yeah.
Okay, so that's read them, sort them, read them, sort them.
Or just pick and place them constantly.
Okay.
Now, many of the items, they have to be handled differently, which is another challenge with robotics. So what a person can do is a person can pull them, it can see where the barcode is, and it can place them with the barcode up or with the barcode not on the bottom. Because as they go through the rest of the system, they need to be scanned to confirm they reach their final outbound destination.
Okay.
It's kind of in and verified out, so that nothing gets lost. And a person is very easy. I mean, they can pick them and handle them, and you're doing it with two hands, so it's not just one motion, and you're able to orient them. Well, when you try to automate that function,
it's hard.
That's a lot harder for a robot. It's because it's not the picking, it's the orientation and scanning that becomes the
really
challenge hard. Because they can't do it as well as a person at that speed.
Also, I imagine, so like we just walked around the facility here and I think every gripper that I saw was vacuum related, as you said that they are.
Correct.
And so it's little suckers that pick things up.
Correct.
And so with that, I imagine, and you were saying how the forces at different angles might like pop it off. So if you hold up an object at 90 degrees, like rotate it from down to up, then the force is kind of uneven on the sucker, makes a
shear motion.
Yeah, shear motion, and then it's very likely to like leak a little bit and then just fall completely because once you release that pressure,
correct,
then it drops it. So the orientation of heavy objects and things probably would be quite a challenge because of that.
It is. And in some of them, if you're handling boxes, boxes are very rigid. When you pick them, they've got a very rigid surface to give yourself a good seal. And you're able to easily, run it over a bottom scanner that can say, yep, you're right, barcode's not on the bottom, so you're good. Or read the barcode, pass that along.
Yep, and just be aware of where it is.
And just be aware of where it is on the sortation. When you pick up poly bags,
What's a poly bag?
Poly bags are
Is it one of those plastic bags?
They're the plastic bags that you get.
Like the soft bags, the
apparel,
Amazon stuff.
yes, an Amazon bag or a FedEx bag, those quick, even UPS has them.
So you say poly, and that means polymer, which is plastic.
Plastic.
Okay, gotcha.
They come in very different types, and I'm sure you've seen them even at the post office. You've got some that are the plastic, almost rigid mailers, but they have some structure to them.
Okay.
Then you have those that they're a thicker plastic, and normally sized to the size of whatever's in them. And then you've got just the general, here's your biggest bag, it's a thin plastic, and you can put anything in there, and you can fold it over, or you can just fold the lid over, and you can put the label anywhere you want.
Yeah.
Now, when you put all those in a shipping container or an outbound container, they all collapse.
Yeah.
So when you dump them, and then when you go to pick them,
They're
where
just chaos order.
Where that barcode is,
or
where the label is, or whether or not there's wrinkles in it or not. Create a challenge for how do I pick it up, and if I pick it up, how do I guarantee that the barcode, where is that barcode, and how do I read
on the barcode?
Even if you're picking on it, that's okay. But how do I make sure it's not on the bottom to do a read if it's crumpled?
So it's visible, for sure.
And so when you start dealing with all of the different package types, that's where some of the nuance around the system design comes into play.
Okay.
And what we're seeing is a migration of package types. And one of the things that the e-commerce explosion has really brought to bear is the returns business. And the returns are everything that person returns because They ordered 3 sizes, not knowing which one fits, and now they're sending 2 back. They don't package them the same.
Nope. Oh, so that's chaos.
That is chaos. So you now have introduced a whole new subset of package types that are going back into the distribution process.
So it was really hard because there's already a variety of package types and you can have anything in it. So like it can weigh anything or I don't know, these plastic bags, it's the shape of whatever it is, hard to pick. But then now you have this giant returns because everyone is buying things and then returning them, and those packages also have to go through that same routing process.
Correct.
Where they're sorted and sent to different places. And so I'm just thinking of the Amazon packages that I send back and the chaotic box arrangements where it's like jammed. Like they always make them fit so good. And then when I pull it out and try it and then shove it back in the box is like all bowed and everything.
Yep.
And so I'm imagining just the chaos that you see in the return. It's like, so we were starting to structure things.
Right.
And make it so we were starting to solve the problem. And then it's like all the returns now and you have to do the same thing and that makes it way, way harder.
It does.
That's so funny.
And because at least from a normal shipper, from a manufacturer or from
more standardized.
It's very standardized because they standardize normally on the size of envelope, size of box, because they can't have infinite number.
Yeah, for sure.
They open, fulfill, seal, label, and out.
Yep.
And that is their constant pattern. But when you now get people who are mailing things that aren't following all of those normal general manufacturing, standards, you're dealing with a whole nother set of packages.
Yeah.
And you're finding that is becoming a larger component in what you're having to
the total volume of
packages. The other thing that is, in an effort to save just cost of shipping, people are starting to put labels on the original item itself.
Whoa, yeah.
So now things aren't in paper bags or white
like
plastic bags or whatever. It's, your razor.
Yeah.
And you just, on the back it's flat, so you just put a label on it and it doesn't matter what the front is.
Yep.
And so now that is becoming, items that you're going to have to deal with in this sortation process.
That's so funny.
So you're making it more and more and more complicated and chaotic, which is why, vision and AI and just that level of advancement in being able to learn and recognize and understand, that's why that is so important, is because it's continually evolving and it's continually evolving to chaos.
Yeah. Because convenience probably is more chaotic and we're going towards convenience.
That is true.
Interesting. Where do you think, so if it's just putting it on the product, is there anything else that could be done that's more chaotic, that increases the chaos from the perspective of the warehouses that are doing the routing?
I think what is the most difficult is when you're in the warehouses or when you're in the manufacturers and you're putting those items in the packages, your sealing methods are very regulated in that you've got glue guns or you've got seal tapes that adhere to, a standard that you've engineered into that distribution chain.
Yeah.
Now, when people are doing it, all bets are off. If they've got duct tape at home, they put duct tape on it. If they have painter's tape, they put painter's tape on it.
Yeah.
So you tend to see a lot of opportunity for things to open in the process, even more so than you would in their original shipment. There's always potential for that, but when you start dealing with a lot of returns, individuals are not as careful about understanding how these products are going to be handled throughout the and they use what they have on hand.
Yeah.
And in a lot of cases now, they're not even monitored. I mean, remember, you used to have to tape it and do it and then take it to the post office, and there was a person there who looked at it and went, "You're going to need to tape that over there." And so, they could look at it. Well, now you have auto dump, you have automatic drop off, you have automatic pickup.
Yep. Oh, wow.
Those people aren't necessarily gauging how you've, put your return back into the box.
Yes, for sure.
So
That's
that
funny.
makes it not necessarily from a recognition perspective, but from a physical handling perspective.
Then it becomes
It
challenging.
becomes challenging because now you have more potential to have a failure at the gripper.
Yep.
Just because of not having
Unregulated
unregulated
boxes,
box
basically.
sizes. Yeah.
So like you have a box, you try to pick it up, it rips because they use painter's tape to seal it.
Second, it opens up,
Yeah.
half the contents spill out.
Yep.
What do you do then? So you need to make sure that you understand what the problem is, because a person can see it. They can see it and know when they're before they even go to pick it up, that
This is a sketchy box.
This is a sketchy box, or this is
did
going to be a problem, and I'm
Yep.
just going to move it. I'm not going to try to handle it in one plane. I'm just going to pick it up and move it to the reject pile or to the reprocessing pile.
Or like put it in a bigger box or something.
Which that's what they do.
wow.
A lot of times they will look at it and they'll repackage it into either another box or another package size that then has another label. So it's a package in a package, but
Yep.
it's not something
it's at
that's
least contained.
ripped or open that's trying to go through the automated machinery later that can cause jams or something downstream.
Okay, so this problem sounds really, really hard to me. And I'm thinking back of all the like terrible things I've sent back and the terrible ways I've done it. And I realize I'm making it really hard on the distribution.
Well, you're not making it hard on the person, but you do make it
Yes.
difficult for
The robots that
it
do
to be
it.
automated
Yes.
easily.
Uh-huh.
So that is the challenge.
And what's the reason that we don't just have a heavy hand with this and say all things go in this box? Like this set of boxes that have incredibly robust walls and will never rip or not never, but very infrequently. Like, why not just like force really good boxing practices?
Most people do from the manufacturer. From the consumer, they normally
Totally different.
don't. If you look at when you go into, say, the post office or any of these other places, you'll notice they give you an option of boxes and bag sizes. But a lot of people don't use those. They use some container
That they
that
had at
they
home.
had at home,
Yes.
and were able to do that. And then if it's really bad, what I've seen them do is, then they put paper over that and then they tape it all up. It's very interesting because in a lot of cases, labels have been made specifically to be read in a lot of different high-speed applications. When you take a return label and then you put it under shiny tape,
Yeah.
that's not how it's normally applied. It's normally
Yeah.
applied on top and on the outside
Yeah.
to be easily viewed. All of a sudden, now you can't even read it with your barcode label because you get too much reflection.
Yeah.
And so it can kick out. And so it's amazing how many challenges you see more in the repackaging of items than
Yep.
in the original packaging. I think from an original packaging perspective, there's a lot of effort made into, hey, how do we become more sustainable?
Yep.
You
What do
see in
What do you mean
in
sustainable? Environmentally friendly?
environmentally sustainable,
Ah, okay.
being more conscientious about the environment and the types of things that we are throwing away at the end of the day
Yeah.
when you receive these packages. You see in Europe is making more of a transition away from plastic
Okay.
and more into corrugate and boxes. Those are easier to handle
Okay.
than when you have all of the flexible plastics. And so you do see a difference between different countries in, the level of complexity relative to the handling challenge. You still do have the same issue with repackaging,
Yes.
but most of the repackaging is still in
Boxes
in
instead
boxes.
of bags. So bags are really one of the tricky spots, it sounds like.
Yes. So think about, I'm sure you've received something that was in one of those bags and you cut it open and you returned it, and instead of putting it in something else, you just
Taped it
folded
shut.
that and then you taped that edge that you cut shut.
You know me, yeah.
Well, you're not the only one. I've done it too. Well, that can make a challenge when it
Yeah.
has to be rehandled.
For sure.
And so it just, you don't think about it when you're doing it, but all of those things are really making it the handling challenge, which is one of the reason, one of the things I love about Plus One is, not only do we have the software that provides the eyes and provides the pick points to allow it to be handled, but it also has the human in the loop function
Yeah.
that can help with addressing all of those exceptions that we just talked about.
Yeah.
That make it super challenging. That's one of the things why we say, robots work, people rule. Robots are very good at doing very repetitive things in environments, even in unstructured environments that are easily discernible. They have now with the AI and all of the different models and the deep learning concepts, they're able to be able to adapt to their environment. But that only helps on the imaging side. That doesn't necessarily help on the picking side, on the actual engagement of the end effector to the parcel.
Yeah.
And that's the part that a human is the best at classifying, because they can look at it and go, yeah, that's never going to work. Or it's just off center, the weight distribution is just different. If I pick it just right on this edge, which you would never teach it to do,
Yeah.
I know this package will pick up well. Well, if you allow that to happen, now the robots are able to continue. They're always going to find that one thing. They go, either I lost it or I can't pick it.
Yep.
How best do I handle it?
Yeah.
And I don't want a person to come into the robot cell. And I don't want to stop the process.
Yeah.
And I don't want to eject it, because that's another method of handling things is you just eject them and then reprocess them. But when you do that, now you have another labor component that somebody has to take everything you've rejected and reprocess it.
Yeah, for sure. Okay. So you mentioned a little bit about your setup at Plus One, but tell me about the systems that you guys work with, or that you guys are creating here at Plus One.
Right. So we have two specific products that we are actively launching.
What do
what
you
we
mean
call-
actively launching?
Actively launching means we're putting them in customer facilities and turning them on for production to be able to use. We have probably the most in production to date within each picking or singulation, parcel singulation. And that is our primary and our
Single
very
parcel.
first
That was your niche.
application is parcel handling and parcel singulation. And that can be out of bulk, out of a tray, out of a tote, whatever it happens to be. But normally, it's an inbound flow that we then singulate to go to a sorter that takes it to the next outbound destination. And so it requires it, and it's around parcels. And what we mean by a parcel is it's in the shipping container. So
shipping container?
Yeah, so there's a difference between each picking and what we call parcel picking or parcel handling.
Okay.
Parcel is in the outbound shipping package that it's going to go in transport.
Okay.
And each is placed in one of those bags. So think about if you were doing something, Walmart, Amazon, they all have a whole bunch of things that are a box of pens, a razor, or whatever that they put in a plastic bag or in a box and send.
Yep.
So the razor, the pen, all of those are eaches.
Yep.
What they put it in is the parcel. So what we handle is all of the small group of the shipping components. Now, because they're starting to label the actual
that changes
containers,
it, so now it's the same problem.
But it does change the problem.
Yep.
And it's now allowing eaches to become parcels.
Yep. Yeah, that's what I was meaning. It was making exactly. So the parcel problem is becoming the each problem.
Yes.
Interesting.
Each is much more difficult because of the variety and the method that you need to handle it.
Yep.
Whereas normally on your parcels, you're able to get utilize vacuum versus having to do grippers or any of the other components to reorient.
Yes, because you know kind of the outsides of it. You know it'll be a
Correct.
plastic bag or you know it's going to be a cardboard box. And both of those work with the vacuum suckers.
Correct.
Gotcha. Okay, so you have the two products?
Yep, so that's parcel singulation.
Parcel
and then
singulation.
the second one is mixed depalletizing.
Uh-huh.
And envision the exact same thing, but now you're coming in with a pallet of something
Yep.
that you have to, that a pallet is a bunch of different boxes or containers that are in a pattern on a wooden pallet that's how they're transported by truck.
Yep.
Normally they have shrink wrap around them for stability.
So they don't fall over.
And the reason that they're mixed is now you don't have the space to store full pallets of the same thing. Now I need, if you're looking at, now I need boxes, if you're doing a pet food, for example, now I need boxes of, Purina, what's the other one? Blue, what's the other?
Oh, I won't know anyway.
Doesn't matter. All of the
A bunch of
different
pet food stuff.
manufacturers. But I need 5 of each. So
Yeah.
I'm going to have a pallet with 5 of one, 5 of the other, 5 of the other, and then I need it to come in.
Yep.
Or if you think about things coming from a Target or a Walmart or any of your superstores, mixed pallets are things that they need to take from their distribution to, say, a
One
mid-level
store.
or to their store. And they don't need an entire pallet of Pepsi. They need some
Something.
Pepsi, some Coke, some, Dr. Pepper. That they need a variety because they're not storing that anymore. And what
Yeah.
that means is that those pallets no longer have a regular geometry. That is a known pattern. Palletizing and depalletizing has been done in manufacturing for
Forever.
the last 25 years.
Yeah.
But they're known patterns.
Yeah.
And how they're traditionally handled from a depalletizing perspective is they're done in layers. You got a big robot head that comes up and it picks the whole layer off, and then it descrambles it and it puts it, it singulates it. Well, these things aren't in true layers anymore. You've got boxes that could be 2 by 3. You've got boxes that could be 4 by 8.
Yep.
And they're all
like
nicely
Tetris, basically.
Tetrised on top of the pallet.
Ah.
And now you have to offload that because they have the same issue. It has to be now distributed down to the store or the convenience store, and they don't need the whole thing. So that pallet is then taken, singulated, and then redistributed to then be palletized again for its next outbound destination.
Wow. Yeah. Gosh, the routing problem.
It is.
What do you call it exactly? What's the problem called?
It's cross-dock,
Cross-dock.
cross-docking.
So that's going from pallet to another pallet, but you break it up and you reorganize it.
Correct.
And so it's this process until you get finally to the shelf
Correct.
often, or to the person who it was ordered for.
And so what you'll hear in industry is aisle-ready pallets.
Ah, so you can just shove them right in an
So
aisle.
that you can, no, it's for when the
Oh, it has
person.
the whole aisle?
So when the
of
person
mixed items?
is restocking their shelves, they're pulling that pallet behind them, and
just
they're
putting-
doing all the way down the aisle. And so they have been repalletized how their aisles are.
Wow.
And so
That's
that makes it
sophisticated.
easier for them to replenish
Yep.
their shelves. And but in order to do that, you have to take, some of the others from bulk,
Yep.
then get it to it, then redistribute it, then make it.
Yep.
And so it's just a constant method of, distributing whole loads to partial loads. They used to not do that as much. They would have room to store everything.
Yes.
But with just in time and with inventory and with trying to reduce their footprint,
Yep.
they're really
People
trying
want
to
it
make
go
sure.
in and out at
Yep,
the same
very
time,
quickly.
rather than we have this giant warehouse of stuff we're storing
Correct.
to eventually sell. Yeah, it's interesting. All this just-in-time manufacturing, just-in-time shipping, just-in-time whatever. It's an interesting model, and I guess it makes it easier to just efficiently go through things rather than storing them, losing them in storage, these kinds of things.
Right. And, really that's one of the reasons it's necessary to have the 3D vision and the AI is to be able to recognize all of the different things that could come in a pallet.
Yeah.
And it's not in a consistent pattern, and you need to understand what it is, how to pick it, what's around it. Is it unstable? Is it not unstable?
And by that, do you mean like going to rip open, or what do you mean unstable? Like tippy,
The pallet
tip
can
over?
be packaged very neatly and I want to say overlaid to where as you're picking it, you never lose the stability of the pallet itself.
Yep.
And then you have those that have a bunch of little things and big things all on the same pallet. So if you pull the big things off first,
You lose the structure.
you lose the structure, and so all the little things become unstable. And so when you go through and look at how to deconstruct it, you need to do it in such a way that is going to keep the integrity of the pallet.
Okay. So you do those two problems, parcel singulation,
Parcel.
and then
Or parcel induction.
parcel induction. What does the induction refer
You're
to?
inducting it into a sorter or something else.
Okay.
You're pulling it off and inducting it into something else.
Gotcha.
So you hear it referred to as induction applications, but it's really parcel singulation. That's what you're doing. You're singulating it from a pile.
Yep. And then the second one is the
Mixed depalletization.
mixed depalletization. Gotcha. And then, so how do you, sticking first with the parcel induction, what does your system look like for doing this, and what kind of sensors do you have, and like what's the general setup?
Okay, so the general setup, normally you will have feeding your product is either a large belt, a chute, or a small induct
This is what we
conveyor
were
line.
looking at in the video when you gave me a
Correct.
tour. I see.
Correct. And so that brings the materials to the robot.
Yep.
And then the system is a robot, the end effector. You have 3D sensors. So we happen to use RealSense,
Intel.
Intel RealSense sensors on our systems. You normally have what we call our smart lights, and smart lights are able to be changed in their luminous intensity based on your environment. So in a dark room, you would want something that has a little bit more light, that provides something that's consistent.
Is the goal to keep the lighting consistent for the cameras?
For the cameras.
Ah.
So you want to make sure that you don't get reflection, and that you can see contrast as well as you want to in an environment.
Do your smart lights use ways of like diffusing lights and things so that they don't have like a harsh direct light that's
We have some that have diffusers, and then we have
like
the
in
ability
photography and these kind of things?
to dial down their intensity.
Yep,
And
so
so
those
we
two
don't
things.
dynamically use it. We set it for what is optimum for the process.
Okay.
And it stays that way until we need to reevaluate or recalibrate or recheck the exposure. The reason that we have gone to those types of lights is that once you get into a plant, you can't determine exactly what kind of luminosity you're going to get just from your fluorescence. And you don't want to be subject to one of their light bulbs going out, or the fact that you've got a fluorescent light right next to one side of the cell
But
and not the other. And so by providing a consistent lighting for the operation, it just
Much
makes
easier.
the system work much more functionally. So you have the lights and the cameras, and then we have a gripper. Normally it is a vacuum-based gripper with 1 to 7 cups, depending on the size of your the product that you're trying to handle. And then you have a takeaway conveyor or whatever you're placing on, and we can place on an outbound conveyor, an AMR, a tote.
And that's autonomous mobile robot.
Yep.
Okay.
Those are the small little robots that are
go
now
out it further.
replacing conveyors. Really, they're
that's so cool.
transport now
Yeah.
versus having conveyors. So they're a little bit more flexible in their orientation, but they do compromise some speed applications because some of the high speed conveyors can go super, super fast, but it provides the flexibility around, the process that you're working on. So the whole idea is just to pick from bulk and place as a single, validate that. We do place verification.
Okay.
With another camera, and that verification is looking for Did you pick a double or not pick a double?
Mm.
Is it, in the orientation you wanted?
Okay.
And, did you place it in the right position in the zone?
Mm-hmm.
And so if all those things are yes, it continues on.
Sends it on its way.
Just sends it on its way.
And so for if you do have the rollers that you're placing it on for the outbound,
Yep.
do you have several different ones that it could place it on? It'll be like one of 3 different roller sets, or
Normally not.
how do you know, like, how do you know where it's, I guess you scan it and then there's something that switches it downstream to route it, or how does the routing work?
Yeah, so
from there?
so normally these are entered onto what we would call a sorter, and you can have a cross-belt sorter, a Euro sorter with a dump, a linear belt. There's several different kinds of sorters, but basically what they do is when they get a read on the barcode,
Yep.
they query the system, and the system says outbound destination number 12.
Yeah.
And it takes it to outbound destination, and then it puts it off of it into it. So either it'll dump it, slide it, or
Whatever
convey
it'll
it
do.
off into that outbound dump.
So the robot's role, in a sense, is to just scan
Just
the parcel to know where it should go.
Singulate
Pull it out from the thing.
and scan the bottom.
Yeah. And scan
Normally, all of most sorters
Mm-hmm.
have top scanners.
Mm-hmm.
They don't have bottom scanners.
Okay.
So if you can't flip it to make sure it can get it, you have to read it first
Okay.
before you place, so that it has a barcode. It has
That's
knowledge of
registered.
where it's supposed to go
Yep.
in the system.
Gotcha.
And we have applications where we're just picking and placing because we don't care where the barcode is. We have applications that we have to pick and place and make sure that if the barcode's on the bottom, we have to pass the barcode to it.
Mm-hmm.
Or if we pick and the barcode's on the bottom, we have to flip it
Yeah.
so that the downstream process can do it. So you have 3 different ways that the outbound can go.
Yeah.
And each one is slightly faster than the other. So if I don't have to do anything with it, it's
the
its
best.
fastest.
Yes.
If I have to scan it, but I can pass the barcode on it if it's on the bottom, okay. If I have to flip it, now we've got another motion. Slows the process down.
Yeah, for sure. And if you have to flip it, well, actually, going back just a little bit, why do you guys? Why are suckers used? Why are vacuum end effectors used to pick up things as opposed to anything else? I suppose it's like the variety of the boxes and the size of the box. Like you can't have a gripper
Correct.
that is massive for the massive boxes, but you can have one fixed vacuum sealing or vacuum
Right.
gripper.
Well, yes.
Is that why?
That is why, because of the variety of size. You can always zone your gripper to make sure if you've got little things, I'm only engaging the vacuum on one
One
cup.
suction cup,
So
yeah.
I don't have to worry about picking up any on the outside. But if it's a huge box, I've got a big
All of 'em.
footprint that I can use all of them to handle the weight that might be associated with that. When you try to do that with some sort of gripping function, you have to have a more dynamic tool. It's a
Yes.
little bit more complicated,
Okay.
and the process can be slower. So for a vacuum, if I've just got to go over and just get a little bit of suction, that's one of the fastest that you can do versus I've got to come in, I've got to grasp, and then I've got to move. Especially if I have to move my tool.
Yeah.
And you're really looking for simplicity. I mean, you're talking about in some cases, 1,000 picks per hour constantly. That's an incredible number of cycles in a day, in a week, in a month. And the more simplistic a tool is, the easier it is to maintain.
Oh, that's
So
interesting
you've got to
from the
think
maintenance
about
perspective.
long term.
Yeah.
This is a maintainability play, and an ease of if something did go wrong. If I lost a vacuum cup, that is easy to replace versus if I've damaged a gripping finger.
Yes.
And so
Oh, that's
when
so
you look
interesting.
at it from a long term and a reliability and maintainability perspective, the most simplistic tool you could provide is a
The best
vacuum
one.
cup.
Uh-huh.
Now, can you get everything and can you manipulate in all the ways that you need to? it may provide some challenges in that regard because, again, trying to tipping on shear, you're going to induce forces that the grippers are never meant to handle.
Yep.
But for the type of applications we're doing, they happen to be the fastest and most reliable type of end effector that we can use.
Gotcha.
And it's one of the simplest relative to identifying pick position. When you're trying to do grasp positions, you have to...
Oh, it's super complex.
Yes, it becomes a much more complex problem versus...
How do I find two spots to like go through it so it doesn't shoot out when you grab it? And
Correct.
There's a bunch of contact force related challenges there.
There is, and there's work being done on that all day long, right?
Yep,
and
for sure.
So there's a lot of work being done in dexterous manipulators and being able to quantify and identify. But you can't get the speeds for the type of applications we're
that you're
using
trying to do
at the moment. Will they get there eventually?
Maybe.
Yes, but it's a much larger challenge relative to the complexity of the algorithms on the AI perspective to be able to accommodate all of those different scenarios with the same type of gripping strategy with the same type of gripper itself.
Yes.
And so for us, especially since we're handling outbound parcels, they tend to have more consistency.
Okay.
And I only have to lift and place. I don't have to manipulate. Now, the minute that I need to manipulate it into a put wall or try to manipulate it into a tight package box, okay, now all of a sudden you have to think about the type of gripper that is best for that type of orientation development. And for us,
that's not the task you're solving.
That's not the task we're solving.
I see. Gotcha. It's interesting because it seems to me that this task, it's very much one that you care about how it scales. Like you're going to be doing 1,000 picks per hour for continuously for like, I don't know, how long, like how long are these robots expected to be in operation when so if you have one robotic arm and it's doing the 1,000 per hour in a factory somewhere or in a warehouse somewhere, how long will that robot typically be in operation? Is it like 5 years, 10 years?
So they're rated actually to be able to do 10 to 15 years.
That's insane.
Right? But you'll see some of them
times
in
24 times 365
so
times 50.
so you'll see that
in
automotive. I mean, you've got robots that have been there 20 years.
Yes.
And they're built for longevity. And for what we try to maintain, for the most part, we outline that we're looking at 5-year contracts because at that point, the technology will have changed enough that we will want to upgrade.
Reevaluate your solution and find something given the current technology.
Exactly.
I see.
And really it changes sometimes more rapidly than that.
Yep.
But for the most part, if you're already making that metric for the throughput that you need, the next generation is just going to give it to them a little bit more, but they may have to reconfigure.
Yeah.
And you don't want to necessarily have to modify your processes in facility or in plant, that
drastically.
often.
Yeah, you
So-
want to reuse most of what you have, maybe
Right.
upgrade this one part here. So
Correct.
like software, it's like modularity is a good way to structure
Now,
it.
the software will continue to update and
for
maintain throughout the life cycle, but your IPCs, your cameras, your industrial.
any acronyms.
Yeah, I'm sorry, industrial personal computer. So it's the actual housing unit for the CPU and GPU.
I see.
So we'll have. You'll want a different form factor, or maybe the GPU needs to be upgraded, or it's getting old. Let's upgrade that technology. Same thing with your cameras. You're going to have new cameras, better cameras, more
Everything.
depth-rich camera. I mean, so
And
we
things
want to
change,
make
too.
it to a point where, okay, at that, the robot will still be repurposed.
Yep.
If you've maintained it properly, it
could
can
still use it.
continue and continue and continue.
Yep.
But you may want to upgrade some of the other technology pieces because technology has moved that fast.
Yes.
And so I expect that you're going to see those things at least for a 5-year period, and then you'll want to upgrade. Some cases you may do it in 3, but
Wow.
it really
It's
depends.
so cool to see it.
Really
moving
depends
so
on
fast.
the system, right?
Yeah, and it's almost like energy or something, like for your house, where you want it to basically have a certain amount. So you want this many kilowatts per month or something to live on.
Correct.
This, you want this many parcels per unit time to go through.
Correct.
This kind of thing. So if you build it for demand, or like building highways or things like this, like you're expecting this much throughput, and therefore it could be a good investment now for the foreseeable future, given what you'll expect. Or you could just have additional facilities brought on to distribute the load onto.
Correct. And normally what the clients end up doing is when they put a new facility in, they plan it for what their volume is now, and then they plan
They
for.
probably project.
Oh, they project way out. So
Yeah.
they want to make sure that your systems that you're bringing in
Will last.
and can support them through that expansion.
Yes.
And so you're planning at the onset to be able to do that as they're working. And so as you need to make changes, or you need to make upgrades, or you need to add robots, you can do that as they migrate to their increase in throughput and production speeds and volumes. And you can go from 1 shift to 2 shifts to 3 shifts.
Yep. Oh, that's nuts.
6 days, 7 days a week, 5 days, 6 days, 7 days a week. So they have a lot of flexibility when they start the facilities.
Oh, yeah.
They can start it with a, single shift, 5 day a week. Then, then
Ramp
move
up.
and ramp up accordingly as their volumes increase.
Yes. And then so how does, now we've talked at length at the beginning, all of the challenging boxes and all of the challenging parcels that people may be sending for this. Would you tell me a bit about handling those, or
Yeah,
how you
so
guys deal with those?
how we deal with those is there's only so much that you can really evaluate from a top view, single camera, single plane view, about the integrity of a product. So on the things that we can infer from different learnings of different images and handling practices, we still have to be able to deal with the situation where, the package does fail, it does come open, something is different than was expected, and the system just, it says, hey, I don't know what to do. And we've incorporated, our human in the loop portion, which we call Yonder, that are also run by what we call our crew chiefs, who are on, call, that when any of these robots initiate a request for help, they're on call, and it pops up in a 2D frame to be able to say, here's my situation, what do I do? And a crew chief has the opportunity to help the system by identifying a variety of different things. It can say, you just don't know your pick point, let me help you. It can say, ooh, something's open.
Yeah.
Let me tell you how we can maybe handle this, and we need to flag it for, to be put off. Or, I cannot handle this at all. There's a mess. We need to call for help.
Gotcha.
And so in all of these cases, the majority of the time, it happens to be this is really different. It looks like it might be compromised. I need help to determine what to do. And a crew chief will go through and say, nope, we can pick it.
Yep.
Try to pick it a couple of different times. If it fails once or twice, at that point they'll make the decision of, hey, looks like this is something that can't be recovered. We're going to call for somebody to come over and help at this point.
Yeah.
But the other thing that can occur with this is if you've noticed that for whatever reason, it's not able to pick something that it picks every single day. We can, through the crew chief can say, hey, why don't you go, check your end effector.
Oh, yeah.
Okay. And it can either go check it with, and check its pressure, or it can tip it and let the crew chief look at it and go, oh, we have cups missing, or, oh, there's something broken, or, oh, you have lost your pressure.
Yep.
Well, in that case, there are a couple of different, intervention capabilities that we can, have it do. We can say, okay, call for maintenance. Again, call for help, and and the cell will initiate somebody to come over. It can say, oop, you know what? We're going to do a tool change. because we're in a high speed and high volume. I don't have time to have somebody to come do that. I'm going to tool change,
Yep.
call them, but they can fix it on their own time because I have a new tool.
Yeah.
And so there's a variety of different methods that or actions that the crew chief can command based on what they're seeing and the knowledge of that system.
Gotcha. Very interesting. That's really interesting to me that it can be used for, like, so I understand the efficiency gain of, this isn't working, we need to have a person come and help it. Or, like, that's really interesting. But then also going, oh, our tool might be broken and this kind of thing, almost like keeping the behavior as expected for the products. That's very interesting to use it as like a monitoring, a way of monitoring the system in a sense.
Right.
That's surprising.
Because they know, especially when they get 2 or 3 calls in a row from the same robot.
They're like, oh, it's that one.
Something's not right, because these should be easy picks.
Yeah, for sure.
If they see that, it's very difficult. Oh my gosh, these are really bad poly bags and they are really crumpled, or it's partially open, but I'm going to try to do it. That's a much different scenario than I'm dropping it on something that's a box that I should be able to pick every single day.
Yes.
All the time. There's got to be something else going on
with the system. Yeah.
And without, and it's because it's being asked for.
Yep.
Right. And they wouldn't notice if they weren't being called.
Yes.
And so they're going to know there's a problem well before anyone in the plant knows that there's a problem.
Yes, for sure. And they can try to address it too.
Correct.
Or call for help if it's necessary.
Right.
Very interesting.
And what that does is that, all of the metrics relative to automation are gauged on mean time to repair.
Okay.
And mean time between failures.
Mean time, average time? Okay.
And so the goal is to reduce all of those things. So to have a person intervene, no matter if it's a simple
Always
solution,
time-consuming.
it's very time consuming. To have a crew chief intervene, we can do a request and a response within
Super
5
quick.
seconds.
Yeah, that's nuts.
and so you don't even really notice that there was an intervention.
Yeah.
If you were standing there, you really
Probably
wouldn't
wouldn't even
notice that there was an intervention unless you were just standing there really watching it, especially on
And
the
you
high
also
speed,
knew.
because it's always doing this. So you might understand a paused.
momentary pause is like, oh, someone went and
But
looked
then
at it.
but then it continued. But you don't even have time to react to get over there before someone else has solved the problem.
For sure.
And so in that case, you're able to deal with a lot of the unknowns and still maintain that throughput, because really your mean time to repair is so quick that we're not even really catching it's not really a failure. It's I don't know what exactly it is.
It's a stumble.
It's just a stumble. It's not a failure yet.
Yeah.
And that's important because you're judged by your throughput.
Yep.
And also how easy it is to recover your systems. And when you have a human in the loop that is only calling over a person when there's absolutely no recovery that could be done without a person physically touching something, that's very powerful.
Yes, for sure. Yeah, imagine having like big factories somewhere, or I keep saying factories, big warehouses that are full of robotic arms doing parcel sorting. I imagine that before this kind of approach with the human in the loop to help it make decisions, I imagine it's like, this one's down. Then someone goes to it, takes forever. Simple fix, moves the thing. It's for some reason it couldn't pick it up. Then this other one's down. It's like they're constantly going and interacting with the robot for all these simple cases that are wrong, that are probably not like if the robot just tried to pick it here, it might succeed.
Right.
Pick it on some other side of the...
Correct.
So then it's like, to me, the person is a bigger loop. And when you do this, your crew chiefs, the people who are watching the arm and then giving it occasional direction, it's a smaller loop.
Yes.
It's a quicker round of feedback for the robot. And so that helps you tighten your metrics to reduce. And so it's a really interesting thing. It's like the grocery store model of doing things, with the one person having control of a bunch of self-checkout kiosks. kind of thing.
Exactly.
Now you have one crew chief watching. You told me it was how many? 20 to 40 robots?
20 to 50 robots.
So many.
So it depends on the application, but
Yeah.
20 to 50 is what, you know, the goal is. And, you know, the more you can do at 50, the better. But
Definitely.
it really, with it varies by mix, what you see on that day, what came in.
What items there are. Yeah.
What items are on it. And it also varies on the type of system that you're working on.
Yes.
You will see a difference in a pack out situation where you're picking and then packing into something. That will have more interventions than a depal, and then that'll have more interventions than just a letter sortation. But then a general shipper that handles a lot of returns will have more than just a, you know, letter and small parcel component. So it varies by what they're doing and what method they use to correct themselves.
Yeah.
If you're not using human in the loop, you have to have a method to continue your process without this. So you can either have somebody come in, which does hit your throughput rates as long as as well as your mean time to repair, but also if you choose, I can't do it, I have to ignore it. You have two choices. You can either index the entire whatever's in front of it off into a what we call a recovery lane or a hospital lane that then is reflowed back into the process, which means you're adding another.
Yep, it's an unnecessary item
process.
to be processed, basically, because
Or
you're going to process it at least twice.
Exactly. You know, or you're actually doing the if it's an order fulfillment where you're picking and trying to do a box. Now I have to take not only the box that I was putting it in, I have to send that to a hospital lane, but the tote that I was pulling it out of, I have to send to a hospital lane. So now you've got double going to a hospital lane because you weren't able to complete whatever that function was.
Yeah.
Or you have a person intervene. And so different manufacturers choose different options.
Yeah.
If you're more worried about, you know, overall throughput and you don't and you already have a reflow process, just auto ejecting might be okay until you hit a certain volume.
Yeah, because it increases your volume that you're processing.
Correct. And you're dinged for that. So that's another person or labor hour that goes against the efficiency of what the robot was there to add.
Yeah.
Right. And so with that being the case, anytime you have to do that, now you're judged on your rejects, not just on the ability to pick and not place doubles and your AI, but now on the things that you couldn't address, the recovery method now adds labor.
Yeah.
More labor than if I could have a crew chief do it.
Yep.
And I can give you a demonstration of what that might look like in a recovery kind of position. Now, we see this all the time in mixed depalletizing situations. Hold on. So what you're seeing here is a mixed pallet that has a lot of different products on it.
Yep.
And one of the packages happens to be slightly open. Now, you see this in containers that have either been in a truck that's exposed to high humidity or high temperature, or ones that have had a lot of movement in transit because they've been jostled and the actual tape to secure them has given away, or in this particular case, they were repackaged by a person
who did a terrible job.
And well, the robot's going to figure out that it is, and it's going to know that I have a problem here. And so, as you're watching the video, it looks at it and it says, "Oh, here's where I'm going to pick it," and it can't pick it because it's not a flat surface; it's an open lip. and a person comes in, takes a look, and sees that I am actually taped securely on one side of the box,
Yep.
I'm going to pick it on that side, command the robot to pick it on that side, and then flag it to be reprocessed, off the line.
Yep.
If I didn't have this ability, I would have had to have flagged it as something that needed to be handled by a person entering into the cell.
Yeah.
And I would have stopped the process because I could have taken things off of the other side of the pallet, but then I may have created a stability issue.
And then everything tips
And
over,
then-
and then that's a pain.
And then we have to stop, and a person still has to come in.
Yep.
So that's just
Interesting.
one
So it
example.
also keeps you moving is part of the important
Correct.
thing.
And
Gotcha.
we're able to flag it. So when that person
Now
went
you can
through,
go process it.
they can
tape it.
actually say, here it is. This needs to be kicked off because it's damaged or because it's open.
Yep.
And this will come down the conveyor and then kick off to another site so that what you're reflowing to an operator is really packages that have been damaged. You're not sending things, oh, I just didn't recognize. It's already been validated that it has been damaged.
Gotcha.
And so there's a lot of power within the human in the loop. And with the diversity, with the amount of returns that we're seeing, with the amount of effort to reduce how much different stores are having to keep in stock,
Yep.
it's only driving up the reason that we have to have more mixed pallets.
Yep.
And it's also driving a lot more diversity in your
Parcels.
parcel sortation component.
Yeah.
And that's really what we're trying to solve. There's a lot of work. Could we go into eaches? We absolutely could, but this is a hard enough problem.
Yeah.
And what we're doing is we're addressing something that is increasing at such a high rate in the need department when the labor availability is
decreasing.
consistently decreasing.
How is it, like if you had to graph the labor over time, how is it decreasing? Is it like stark difference in the last 10 years? Is it like
So
slowly declining over
It's
the
been
last 50?
slowly
or-
slowly declining over the last, I want to say 50, but the problem is that you have so many that are, if you look at the average age of the worker, just because the number
Oh.
of children that each family is now having,
It's lower,
that
yeah.
it's lower and lower, your actual pool is less.
Yeah.
Even those that don't want to do it. And so you're getting to
Oh.
that point where the older ones are actually retiring and coming out, and you're going to see a stark drop because you just don't have the
people are
people
not replacing
behind
them.
it to replace it. And they don't want to do this.
Yes.
They're just not
Wow.
interested. And so while you don't see you're going to see a stark one because the average age in the countries are changing.
Yes. Wow, that's interesting. I hadn't considered the population level, like age effect on this. So you have the people that are currently doing it and they'll age out of it and new people won't want to come into it.
And there are a lot less of them.
And there are a lot less of them too because of fewer people having kids. I think like, are we below replacement level in the U.S.? Or,
I don't know if we've actually gone below, but I think
but
that
we're pretty close.
we're pretty close to even, if not just slightly
Below.
below. And in some countries, it's actually below.
Below. Yeah, I think Italy and some other places, it's
Right.
actually,
And so you take a look at that, and
it's nuts.
you see the need increasing, and then you see the labor. Not only is there more demand for it, there's
Yep.
less of it, and so you're
And there's
you're
this huge-
creating more and more issues.
Yes, for
And
sure.
so you will see more and more automation throughout
Yes.
throughout that subset.
Yeah, that's one thing that I thought was interesting is in countries where they have a very large aging population, I've seen increasing investment in robotics, and I think it's probably partially to offset the challenges associated with not having many younger people to
Correct.
work in these kinds of things, trying to automate their way out of that problem, in a sense.
I think so. And, really with the advancement in some of the technologies, being able to use the person in the cognitive creative capacity,
Yeah.
where they actually are being used for problem solving versus just tasking.
Yes.
You can leave the tasking to the
Robot.
automations,
Yeah.
and leave the complex problem solving and the creativity to the person. And they can work in harmony and in balance.
Definitely.
And everyone's like, oh, we're going for the lights out warehouse and no people. You're never really going to get to that point
That's when you've solved
completely,
100% of the
because
problems.
you're
But there's
going
a
to
lot of
need, there's always going to be
little
the
ones.
exceptions. There are so many things that you can't control for. The environment, the packaging, the materials. I can tell you personally from dealing with, palletizing and depalletizing, even in automotive, if you get packages from different countries, the specification for their cases, for their tapes, for their glues are
Different.
very different. And so when you go to handle them, the means to handle them has to change. And you can't
Yeah.
tell from outside inspection that they're any different.
Yeah,
A
there's no
person
very
can,
clear
because they
visual
can
indicators.
tactily feel the minute that they grab hold of something. Robots
Interesting.
not doing that yet. There are tactile robots that are coming. You see all the stuff Boston Dynamics is doing and all
Yeah.
of these other things.
And
they're
gel
not
site
they're
and
not
all these
they're not
things.
fully there yet.
Yep.
But in some cases that will be available. Again, for us, I look at it, I want the simplicity. These are 6-axis arms that have been, manufactured for, the last 30 years, that they are becoming increasingly more a commodity.
Yeah.
But they're simple.
Yeah.
And they're very, very good mechatronic components.
Yes.
So
They run
if you
for,
can make
what did
it
you say,
something
15
simple,
years or 30 years or something.
it's
Yeah.
very easy. It's
Keep
very
it going.
maintainable. I love the new interjection of the AMRs, or the autonomous mobile
Yes,
robots,
I wanted to talk about that
where
too. Yes.
we are really replacing a lot of the fixed conveyance with flexible point-to-point transfer that allows for ease of implementation in facilities. And so you see a lot of them, and they're being incorporated in solutions more and more, because they can go into a room this size and still provide some value. Whereas trying to get the conveyors to sort at the speeds for the destinations, you need a little bit more
Lot of
footprint.
space. Yeah. And investment too.
And investment. And you do compromise some speed aspects, but
For the
it really
flexibility.
depends on your business model, on what you're trying to do, and the number of sort locations, and how you're handling your different process. And so that's really exciting, because now you can have an infinite variety of configurations that are providing outstanding process flow. But from our perspective, I'm just picking and placing.
Yep.
I don't care what
Yeah.
I'm picking from or placing to, because I'm imaging in both places, and as long as we can bound that problem, we're good. Which means it's adaptable to all of those different process flows. So it can be incorporated in any of them.
Yeah.
You just have to be creative in how you set up your system.
Yes, for sure. The flexibility is very interesting, and especially with all of the things changing so much too, the demands, the type of products, whatever it might be.
Right.
The warehouse conditions and this kind of thing. If you have different flexible solutions, it seems like a nice way to adapt really quickly, even if you're not optimizing incredibly heavy to one specific type of demand.
Right.
But if you do, if you have those cases where it's like, okay, everyone's going to be ordering this one thing, like where a coal processing plant that's going to be just shipping coal off to places, and you're going to be dealing with coal and nothing but coal, then you optimize heavily there. But if you're taking packages from Amazon and you have like Go tubes and all sorts of like random things going everywhere, then you can be more flexible to the type of demand you're getting, and that's exciting.
And you can scale up and scale down very easily.
Oh, that's true too. Yeah.
So if everybody talks about peak. So one of the largest design methodologies that companies use is they design their systems to be able to handle peak.
Yes. So then you have a bunch of underutilized capacity for most of the time.
Yes. Or you have to spend a lot more money to get that ability to handle your peak volume.
Yep.
Whereas with some of the AMRs and some of the flexible systems, when you have peak, you can pop them in and expand and then take them back out when you don't.
Ooh.
And a lot of them are,
Oh, so
you know, you're able to lease or rent or
Yep.
pay for those that you use. So you can bring a whole bunch in for peak and then you can send them back out. And your monthly outlay
That's so
is
exciting.
effective for whatever your demand happens to be. And so
Yes.
it's really offering, you know, the industry a lot of flexibility on how they're going to do that fulfillment. Now, that doesn't work for everybody,
Nope.
but it allows for that flexibility in a lot more companies that don't have a significant amount of money to invest in capital.
Yes, definitely. I'm really imagining robot as a service kind of model.
That's how we're
Trending.
setting up and trending our systems. I mean, our first ones have all been capital, you know, capex. Everybody's capex, but
What do you mean it's a capital
it's
expenditure?
a capital expenditure, and they're depreciating
buy
it,
it,
and they're
and
coming
then-
and buying it, and then they're just buying software maintenance
Yep.
yearly.
Yeah.
Well, okay, that takes a
That's
lot of
one
money, you know, out of pocket.
And
And
yeah,
so,
it's a big investment for companies
Correct.
all at once. Whereas with the software or robot as a service model, they can go, I need this much now.
Exactly.
And it's a lower price than just buying the robot outright.
Correct.
And you can, I like that a lot. I think that's really a cool model for warehouses.
I think so. I think that's where they're gonna migrate, because it becomes an operation expense
Yeah.
versus a capital expense. And in some cases, at the pace that they're growing, they need the capital for their facilities and their infrastructure
Yes. And also
versus
they don't
their
have,
equipment.
definitely. And then they don't have to have a robotics team as well, because they can just hire a robotics company that does it.
They can. They still need to have somebody in the facility that has some awareness. And the reason I say that is that even for robot as a service,
Yep.
and with the remote ability to, you know, not only crew chief remotely, but if they allow remote access so that you can access the PLC program and the controls or
Is
the
it go
robot
on?
itself, if there is a mechatronic problem, let's just say it crashed the gripper to the point where it needed a repair, or it needed somebody to help back it out.
Yes.
You don't want to have to wait for somebody
To fly over.
to
from
fly
some
over to
company.
do that. Or even if you're just down the street or an hour away,
Yeah.
that's still lost production. So for those situations that are routine enough that we can build in, you know, HMI screens, which are human interface screens, that can do recovery,
Yep.
that tell the robot to go to a different place in a safe manner, that they can extract it, do some maintenance. All of them are very good at, you know, they've had conveyors for years. You know, they've had all kinds of pushers and things that are physical. So if they needed to, you know, replace a cup or replace a spring, that kind of repair is easy for them to do.
Yes.
What they really can't do is when the system vision locks up, or when the IPC crashes, or when something else, you know, catastrophic happens. They don't need the expertise for that, but they need to have on site some sort of maintenance
Like some technician
capability
to the robot.
that can get it back into a safe place to reset to when you can't do it remotely, because it might not be safe for the robot to move. And a crew chief can see that. A crew chief can see if it's stuck in a position that it's not safe for me to try to do it. Somebody on site who has the full purview needs to do that.
Interesting.
But you have to give them tools at the solution perspective to be able to do that. Either the teach pendant has to say, go to a safe place, go to, you know, extract, now go to home, so that they don't have to be a robot programmer. They don't have to be a controls engineer. They don't have to be a software developer to be able to do just basic recovery. All of that has to be built in and designed into the system.
Yes. So you're right. There's definitely a
But they
need for that.
need some exposure. But they're not responsible, right? So robot as a service, for the most part, your maintenance, monitoring of its performance, how it's performing is all, you know, would all be on the the supplier for that.
Yep.
But for their own efficiencies, they will want
there.
someone that has, a general understanding of it, that through a couple of pushes on, some specific screens can have basic recovery.
Yep.
They need to do that internally.
Gotcha.
Otherwise, they're gonna
Have a
wait
bunch of
too long,
downtime.
and really that's one of the things that they have that is the most important is because they are bringing in and then redistributing. They have closed windows of when they have to have that on the truck or on the plane.
Yes.
So there's a window that they have to get everything sorted,
So
and
you
if it's not
need it.
sorted
Yep.
at that point, it's missing shipment.
Yep.
And they get penalized for that.
Yep.
So we need to be cognizant to give, solutions that are able to be repaired and operated easily by the on-site operations teams without having to have that degree in, robotics
yeah.
or
You
mechanical
don't need a
engineering.
PhD in robotics or something. Yeah, yeah.
So, very
Gotcha.
important.
For sure. That's very interesting. And that's an important point with the robot as a service model, where if it's going to create downtime and help have schedules slip, like you have to have some way of getting it back on track. And so probably an on-site person to do that would be the way to do it. Interesting.
Even with support. I mean, and
support,
again,
yeah.
we would be on site and telling them how to do it. But again, you want somebody who can be instantly
There
able
and
to
ready.
do that.
Yeah.
And, hey, if the tool is broken or if something that they can't easily just recover, of course, your service provider's coming in to take care of that.
Yep.
We want to design the system so that we can easily get them, back operational for whatever the scenario happens to be. And yeah, we're a software company that enables it, but really you have to envision it in the total solution because it's the
Yes.
solution that's most important. It's not the piece of tech.
Yes, definitely. That's a great point. Yes, I think it's very easy to get caught up in the tech and be like, this is a great thing for the one thing, but you need the whole system
Correct.
perspective because you have to fit it into the system and it has to work well for it to be a good solution.
Correct.
Not just a nice piece of tech right here
Exactly.
in this one part of the process. Let's see. So beginning to wrap up, where do you think you guys are headed in the next 2 to 5 years?
So the next 2 to 5 years, we're working on the unload problem. So we are, working relatively all on the inbound side. If it's coming in from a truck or anything, that we're trying to get that inbound and singulated into the system. So we'll be attacking mixed depal, parcel induction, and all of the applications around those two functions.
Kind of growing out from until
there.
You meet,
And there's so much in the transport from facility to facility in that distribution before you even get to the last mile that needs to be addressed by the sheer volume. That we anticipate that by working to address the complexity that is coming just in those two facets because of the mix of things you have to address,
Okay.
that will allow us to proliferate throughout, those types of companies and then address more inbound components.
Gotcha.
So we're scaling.
Yes.
We're about to, we'll see an expansion here in the next year or two.
Yep.
Because we'll work from developing the tech and the solutions to now scaling the solutions.
Yes. Are you venture funded?
Yes, we have already acquired our Series B funding, and we will be seeking Series C next.
Gotcha. Do you think going public is in the future, or?
We'll see. I think before you go public, you need to make sure that you can operate at scale.
Yes.
And so, honestly, going public is at the D or after.
Okay.
Only because that's where most of the increase in revenue happens.
Yeah. What advice do you have for, say, a younger you? Like when
Younger me, I would say follow your passion. I have had a passion for robotics since I graduated college and have actually been dealing with robots since the 90s, early 90s. And,
Nice.
you know, looking at all their different applications and from welding to sealing to painting, to material handling, and now being able to handle dynamic environments because, you've got CPUs and GPUs that can do all of these things, at the speed of a cycle time, including motion planning if you would wanted to do that.
Yeah.
All of that is making the things that were impossible previously possible now. And you're only inhibited by your creativity. You just have to continue to find where it is now, how it's going to leverage, and then where you want to go. And you don't have to be at the end point to start.
Yeah.
Start at the beginning and you'll get there. And so it's amazing how rapidly the technology is changing. And it's fun. It's incredibly satisfying, and you just have to find that passion and just keep on going with it.
What do you think? So, just in my time doing podcasting and being involved in robotics, I feel like I've seen several like trends pop up in robotics. I mean, one would be like drones, which were pretty obvious. Then you see now a bunch of businesses start making robots that are based on just navigation, basically. So like they'll go around grocery stores or hotels or whatever it may be. Now the one that I'm seeing, which is very cool, is kind of what you guys are doing, which is the kiosk model, which is one person doing the human in the loop stuff. So the company gets the robot to 95% of solving the problem. And then you have a person in the loop that helps close that loop to make it so that you can do more challenging problems using huge human judgment. And that helps them scale and this kind of thing. And I'm seeing that as a very interesting kind of trend in robotics. Where do you think we're headed? What do you think will be the next, like, very interesting areas within robotics or technologies or business models within robotics?
So I think I had a futurist talk at a different when I was at one of the different companies, and he was talking about the avatars that you're going to see with the ability to have the human in the loop. Now they're not just in the loop, but they're actually more controlling of the entire environment, but all virtually.
Oh.
So, I laughed a little bit because I was like, oh my God, we're so far from that. And I mean, he honestly looked me point blank and said, we are not that far. You're maybe 5 years out before you can start testing some of these things. And you look at where all the technology is, right? All the auto navigation. You've got all of the dexterous manipulation that we're working on, right? And when you combine all of that, yes, you will have something that might have the AI intelligence to be able to address a subset of problems. But when you have to do a problem repair or something else, all of a sudden now, how do you do that remotely? Well, now you actually assist the actual device remotely. Either with teleop or the virtual with virtual headsets. So you're already seeing some of that in surgeries. You're seeing that already in NASA, for satellite and space repairs, right?
Yeah.
I think
Healthcare,
I think you'll migrate more and more into being able to do more creative, human-assisted autonomy.
Ooh, that'll be really cool. Yeah, it's kind of the next, you're right, that it's kind of the next level of human in the loop. Right now it's simple decision making. Eventually it's taking total control of the robot and just embodying it for a little bit. That's really cool.
Because you can get there faster. You have that other side of the coin that everybody's worried about. Oh my God, I don't want to make him too autonomous because, then we get into this thing, the Terminator thing. But to be able to do that requires such complex algorithmic performance.
Oh yeah, it's unbelievable. It's gonna be a while.
It'll be a while, but some of the things we want it to do, the way that you get it to be able to do it is you don't strive for that 99% before you put it in.
Yep.
You strive for the 95. You put the human in the loop to do that, and then let it learn and evaluate the criteria by which you need to put your next generation to do. Because I can give you all of the engineering specs around a problem. What I can't give you is all the variations you're going to see in reality. And they don't match the engineering specs.
Nope.
So by having the human in the loop, you get the opportunity to see the things that you didn't plan for. And figure out, do I need to plan for them, or do I change things upstream or downstream of the process
So I don't see
to
them.
eliminate it? And you're going to have factors of both. You're going to have things that you can eliminate, and then you're going to things that you're going to learn that this needs to be, because we can never get around this.
Yeah.
And that's really the key, is to be able to, the only way you scale to put more and more in until the technology reaches that 99.999 is being able to handle the exceptions that come up. And the best way to do that is with a human in the loop. And so that's why robots work and people rule.
Hell yeah. Let's see. So finally wrapping up, do you have any links or contact info you'd like to share with our listeners and watchers?
Certainly. LinkedIn, Crystal Parrot. It's 2 R's and 2 T's. And of course, you can visit our website, +1robotics.com, or crystal.parrot at +1robotics.com. Happy to engage.
All right. Awesome. Thank you, Crystal.
Thank you.
Bye, everyone.
Take care.
That's all for this episode. If you like this interview and want to see more content like it, make sure to subscribe. Also, likes and reviews help a ton. See you next time.